Hello, people, and welcome back to another session. In this session, we'll be continuing from where we left in our previous session. We will be continuing our discussion on simple linear regression. Now, in our previous sessions, we have already gone through the basic equation of simple linear regression and how to find the slope and the intercept of a simple linear regression line that tells you about the nature of association between two numeric continuous variables. Just to reiterate, we saw that the equation of simple linear regression was beta naught cap plus beta 1 cap into x, right? Where beta naught cap and beta 1 cap are the coefficients of slope and the intercept once we have adjusted for the random error using the gradient descent technique or any technique that helps us to take into consider take into consideration the minimization of the standard errors or the sum of squared errors. Okay, so now we will take our discussion forward from here. We also saw that how we can calculate the value of each of these coefficients, beta 1 and beta 0. So we saw that beta 1 cap is equal to r into r is correlation coefficient s of y divided by s of x, and we saw beta naught cap as mean of y minus beta 1 cap into mean of x. This is how you calculate the slope and the intercept of a simple linear regression line. Today we are going to be discussing a very important parameter called the coefficient of determination or R squared. Now what R squared tells us, it tells us about the measurement of the fit of the model. What it tells us basically, let me quickly remove this. What it tells us basically is if I have points like this scattered around and I have a regression line that goes like this, how well this regression line is capturing my data points. This is what coefficient of determination tells us. Also, it can be understood by saying that coefficient of determination measures the variation in the response variable that is properly explained by the explanatory variable. All right. So this is the fundamental concept. So if your coefficient of determination, the value of r squared is on the higher side, it means that your variation in the response variable is explained extremely well by the explanatory variable, which also means that the regression line that is passing through the points is actually capturing the it's actually capturing the points in space really, really well. It is a good fit for the points in space. This is the basic summarization of what coefficient of determination or R square tells us. Now that we understood what R square is and what role it plays, now let us move ahead and understand how do we actually calculate the coefficient of determination. Before I get to the exact calculation of coefficient of determination or R square, we need to understand a few terminologies. Now let us take an example. If suppose this is my regression line, okay? There is a point here called yi. The predicted value of yi falls somewhere here. This is the predicted value of yi or yi cap. All right. And let us suppose that this is a point right here. This is the mean of x, and this is the mean of y. Let me extend this line. So this is my yi cap. This is going to be my y bar. So a couple of terminologies that we'll introduce here. The first terminology that we'll be introducing is going to be the residual component. This is the residual component. The residual component of regression is defined as, I'm so sorry, let me rewrite this properly. The residual component in the context of simple linear regression is defined as the difference between the actual value and the predicted value. So I'll write the residual component as difference between the actual value yi minus the predicted value yi cap. This is the residual component. The second component that we are going to introduce here is going to be the regression component. Now this right here, this is my, take the black pen, this is my regression component. Just so my regression component can be defined as y I cap minus y bar. So this is regression component. This is, sorry, this is residual component. This is regression component. And if you look at the sum of these two, this gives you the total. So regression plus residual gives you the difference between the average and the actual point. Okay. So these are some of the fundamental terms that you're supposed to know once you're actually going ahead and calculating R square. Now this was for one point yi. Okay. Now to calculate the R squared, you need to calculate something called as the regression sum of squares and residual sum of squares. So just like you calculated the residual for one point, yi, you need to do it for all the points, and you need to square them and you need to add them. That is going to be the value of residual sum of squares. Same way for calculating the regression sum of squares, you need to calculate the square of this difference for each of the points and add them. So continuing our discussion from here, my residual sum of square value will be equal to I is equal to 1 to n, considering that there are n points in space. So this is going to be my value of residual sum of squares. It is basically the difference between the actual point and the actual value and the predicted value, and squaring it for each of the points. And same way, for regression sum of squares, go from 1 to n. yi cap minus y bar whole square. This is my regression sum of squares. This is my residual sum of squares. Now my total sum of squares will be given by regression sum of squares plus residual sum of squares. So if I have to write it in equation form, let me write it down properly. This is my residual sum of squares, actual minus predicted. And this is my regression sum of squares. So this is how we calculate the regression sum of squares, the residual sum of squares, and adding residual sum of squares and regression sum of squares gives you my total sum of squares. So now we come to how to calculate the value of r squared. Now my r squared value is going to be regression sum of squares divided by total sum of squares. All right. So basically it is going to be this value divided by this value. And you add summation here. This is going to be my value of coefficient of determination or r square. Now there is a property when it comes to the r squared value for only simple linear regression. Now please remember, let me come up and let me write it here. For simple linear regression, my value of r squared will be equal to my value of small r square, where the small r is correlation coefficient. So please remember, only in the case of simple linear regression, do not extrapolate these results to a polynomial regression or a multilinear regression. Only for a simple linear regression, your value of coefficient of determination equals the value of correlation coefficient. Right? So this is all that we had for coefficient of determination. We will continue in our next session where we'll be looking at inferencing some of the results from regression coefficients or about regression coefficients. So this session that we did today is going to be extremely handy on coming in some of the few sessions that we'll be conducting later in this particular module. So I thank you so much for watching, and I'll see all of you all in the next session. Thank you.